Hello. Welcome back to the channel. So let's continue our previous video and solve one definite integral question on the reduction formula in this video. So if you have not watched my previous video, in the previous video we derived this formula. So if you have not watched that video, I would highly suggest you to first watch that video in order to get the full context of this video. So by using the reduction formula that we derived in the last video, we will be calculating this definite integral over here. But before calculating this definite integral over here, we'll also notice a very important observation which will help us easily solve this question over here. So this question is basically calculating the integral from 0 to pi by 2. If we have to generalize this question, it is basically calculating the integral from 0 to pi by 2 of sine to the power nx over here, right? This is the basic generalization of this problem over here, right? If we substitute n equals 8 in this case, we'll get this integral over here, right? So in order to generalize this, you'll notice that when you have this formula over here and you're calculating the definite integral, you first plug in the upper endpoint into this equation and then subtract it by plugging the lower endpoint into the same integral expression over here, right? When we have to calculate the definite integrals, which we already have been doing in the previous videos as well, right? But you'll notice one thing over here, that if you substitute pi by 2 in this expression, cos pi by 2 is 0, right? So this term will become 0 when you'll substitute pi by 2 in the whole equation over here. This expression will become 0 and this will become n minus 1 by n times integral 0 to pi by 2 again of sine n minus 2x dx over here, right? And the same case with substituting x equals 0 in this equation as well. You'll see that sine of 0 is basically 0, right? So this term will again become 0 when you'll plug in your lower endpoint, which is 0 in this case, in this equation over here. So since in this case, if you plug in your upper endpoint in this first expression, it becomes 0. And so is the case with your lower endpoint as well. If you substitute x equals 0 in this equation, in this first expression, you'll get 0. So that is why whenever you're calculating the integral of the form sine to the power nx, specifically from x equals 0 to x equals pi by 2, that is basically just calculating n minus 1 over n times integral 0 to pi by 2 sine to the power n minus 2 x dx in this case. So this expression over here has no value when you're calculating the definite integral from x equals 0 to x equals pi by 2 of the form sine to the power n x dx in this case. But please note that this formula is specifically for the definite integral of the form where you're calculating the definite integral of sine to the power nx from x equals 0 to x equals pi by 2 specifically. So that was an important observation that we needed to derive in order to simplify this definite integral over here. And you can also try to confirm this left hand side and this right hand side over here by taking a very simpler example. You can take the integral of sine square x from x equals 0 to x equals pi by 2, and you'll clearly notice that when you'll use the reduction formula in that case, this term will become 0 in both cases when you'll plug the upper endpoint into your equation and when you'll also plug your lower endpoint into the equation. This expression will have no value in that specific definite integral in this case. And also there is one more important point about this formula, that your n has to be greater than equal to 0, because you don't want this sign expression to be in the negative power, right? So your n minus 2 power should always be greater than equal to 0. N minus 2 should always be greater than equal to 0. So that is why your n should always be greater than equal to 2 in this case. So these two observations were very important in order to solve this integral over here. And both of the conditions are satisfied, right? In this case, our n is equal to 8, which is greater than equal to 2. And we are also calculating the definite integral from x equals 0 to x equals pi by 2 in this case. So this would basically be, the question is integral 0 to pi by 2 sine to the power 8x dx. And if we use the formula is basically n minus 1 upon n. N in this case is 8. So 8 minus 1 upon 8 integral 0 to pi by 2 sine n minus 2 x dx over here, right? And then we'll keep on using the same formula until we get the final answer or a simpler definite integral expression, which we already know an integral for, right? So if we use the same formula again, this is basically 7 by 8. And since in this case, our n was originally equal to 8, so n minus 2 would be equal to 6 in this case, right? Because we are using n minus 2 and originally our n was equal to 8. So this would be sine to the power 6x. And now again use the same formula. It would be 6 minus 1 divided by 6 times integral 0 to pi by 2 sine to the power 6 minus 2, which is sine to the power 4x dx in this case. Again, we'll use the same formula. So this is 5 by 6. In this case, your n is 4, so it would be 3 by 4. And then integral 0 to pi by 2 sine square x dx. We can use the same formula again, so it would be 7 by 8 times 5 by 6 times 3 by 4 times 1 by 2, and then integral 0 to pi sine to the power 0 x dx in this case, right? So now we have simplified this expression, this definite integral over here. This is simply sine to the power 0x is basically 1. So this is basically 1 dx in this case. And since we already know an integral for dx, which is x, so now we can use the simple definite integral that we have been using in the previous videos, right? So this would become simply 7 by 8 times 5 by 6 times 3 by 4 times 1 by 2, and sine to the power, this expression over here is basically 0 to pi by 2 dx. So this would be x with the endpoints 0 and pi by 2. So now the final answer is, if we plug in pi by 2 in this equation, it is pi by 2. And if we plug in the lower endpoint into this equation, this would basically be 0 in this case, right? So the answer, the final answer for the integral 0 to pi by 2 sine to the power 8x dx would be 7 into 5 into 3 upon 8 into 6 into 4 into 2. And this would be simply pi by 2, because pi by 2 minus 0 is pi by 2. So this would be your final answer. You can also further evaluate this expression over here and calculate the final answer. But if you leave your answer as it is, this would also be considered as a correct answer in this case. So that's it for this video. Again, the main takeaway from this video is, whenever you are calculating the integral, the definite integral from x equals 0 to pi by 2 of the form sine to the power nx dx, where your n is greater than equal to, you can always use this formula. And just as we did in this question, you can keep on simplifying your definite integral expressions until you get a very simpler expression at the last, which you already know an integral for. And then you will calculate the final answer very easily in this case, and you don't have to use the exact reduction formula repeatedly in order to solve for your definite integral in this case, or in these type of questions when you have the definite integral of this form specifically. So feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.